Okay, so here's the summary of what we just covered for 5.3. So I'll give it a chance to sit here for a minute while you guys maybe get some notes done. Okay. And that way anybody that is gonna watch this, which right now we have Blake and Lucas. Not the other way. There we go. Is that right? Yeah, now it can all be seen. Okay. Okay, so let's go to 5.4. This is why I put these all together because they're pretty much just, this is really something you'll use more in side 4. This also though works when you go in, and we'll play a little bit with trigonometry in here, just so you can see some of the trig things. This is very important when you're looking at the trig options. Okay. So the next thing is 5.4. Okay, so 5.4 is titled the triangle inequality theorem. So this is a little bit different. It's not the sides and the angles. This is all about the triangle. So this is triangle inequality. Okay. So that's what this is about. Okay. Whoops, I skipped it. Went right past it. Okay, so what this says is pretty easy. The sum of two, I can't remember if it's angles or sides. Sides, okay. The sum of two sides of a triangle is always greater than the third side. Okay, so if we're looking here, I'm going to say that this is 5, this is 6, and I don't know what this is, but 5 plus 6 is always going to be greater than this side. So we'll call this A. So 5 and 6 will always be greater than the A, or the opposite side, the third angle, or third side, okay? So what does that tell me about A? What kind of links can I have? Okay, so what would A?
A would be less than 11.
Yeah. Is there any stipulation on the other end? Can A be anything that's less than 11?
Can't be a negative.
Can't be a negative. Could it be 0?
No.
No. So we also know that this has to be, A has to be greater than 0. Because we can't have a no side. That's not a triangle if we have a no side. But so angle A has to be somewhere between 0 and 11. So if you start doing calculations and you come up with something bigger than this, it tells me your calculations are incorrect. That's one of the reasons I like this, because when people use the Pythagorean theorem, I see all sorts of things. And if you go back and look, if you add that up and A is greater than these two sides, you've made a mistake in your calculations with the Pythagorean theorem. Okay, so this one is, I mean, yeah, it's kind of nice to be able to say that, but it's very useful in checking measurements because we know that this side can't be any longer than this. Because if it was longer than 11, let's see, 5 added to 6, that would be 11. So what kind of triangle does that make? It makes a straight line, doesn't it? Okay, so if I have 5 and 6 and my other side has to connect, I'd have to go right back on that line. So I would just get a straight line for my triangle. Well, that is not really a triangle. okay? If I had 0 in between them, so that means that 5, let's see, the link 5 is here, the link 6 is here, There's 0 length between them. That's not gonna give you much either, it's gonna give you a straight line too. Okay, a little bit different straight line, but that's what it's gonna give you. Okay, so that's the way you can use this. This theorem is excellent in the fact that you can use it especially when you're using Pythagorean theorem. And if you get an answer where it's larger than the 2, you know you've screwed up. Okay, you need to go back and check your math. Check what you put in the calculator because it's probably wrong. Okay, so that's something to think about when you're doing that. Okay, so that's really what that one says. Now they're going to have you use all of these. Okay, so and it has a proof, and I'm not going to go through the proof. So we're going to do some exercises right now. So we've got. We should put up our 4th thing, but I haven't gotten it up yet. So go ahead and let's take a break. Come back at 9:35. That's 7 minutes. Start wandering back at that time. How's that?